Okay, hello everyone. We are discussing variational principle and corresponding questions. In our last class, we have been discussed this question that we have to use the variational principle and to find the ground state energy of hydrogen atom. Here, trial wave function has been given this one. In detail, we have been discussed. Okay, you just download this note and try to prepare for your exam. And also one question I have been given to you that you have to do by yourself. This one, same. Here you have to find out the ground state energy of hydrogen atom, but trial wave function is a Gaussian one. Hopefully you all done this question. In today's class, we are going to discuss this question. This question number 4. Here, consider a particle of mass m that is bouncing on a reflecting hard floor where potential given Vx equal to mgx when x greater than 0, Vx equal to infinite when x less than equal to 0. Here, along this vertical way, I have been considered x-axis. This is the ball, and this ball is bouncing on this hard floor. This is the hard floor. Okay. So at the surface or x equal to 0 or below the surface, that means this one. For this condition, potential is infinite. That means particle does not exist on the surface, below surface. But above the surface, particle exists and corresponding potential is your mgx. Here, trial wave function not given. We have to construct the trial wave function, and we have to solve this question to find the ground state energy of this system. Here, half of the question I not written. Here I am writing. Consider a particle of mass blah blah blah, potential given this one. Then find the ground state energy by using variational principle. Okay, so already we have been discussed that these are the steps that we have to follow to finding the ground state energy. First we have to write the Hamiltonian, then we have to consider the trial wave function. If it is not normalized, then we have to normalize it, calculate the expectation of Hamiltonian of that particular state. Okay, apply a minimum condition. Here, trial wave function not given. We have to construct. First, according to first step, we have to first write the Hamiltonian. So for this system, what will the Hamiltonian? Here, potential is your mgx, right? Potential is your mgx, and kinetic energy is your px square. Here, px square by 2m, px square by 2m. So if px, that means it will be written as minus h cot square by 2m del d square by dx square, because it is one dimensional dynamics along only x-axis. Here I consider this side is your x-axis and this side is your y-axis. So one dimensional dynamics for this system, the kinetic energy is your px square by 2m. Px is nothing but px cap is nothing but minus I h cot del by del x. So px square will be equal to minus h cot square by 2m d square by dx square, right? And potential energy already given in the question, that is your, this is square is your mgx. Okay, so the total Hamiltonian of this system is your this much, minus h cot square by 2m d square by dx square plus mgx. Now we have to construct the trial wave function by analyzing the dynamics. Here it is given that Vx equal to infinite when x equal to 0. That means particle does not exist at x equal to 0. That means on the floor or below the floor. So particle, if I am going to represent particle as the wave function, so wave function does not exist at x equal to 0. That means psi at x equal to 0 value is 0. And another property of any wave function must satisfy that property or condition. Another condition, always you have to remember that at x tends to infinite, the wave function will be vanished. This is another important condition for any wave function. So that means psi x tends to 0 when x tends to 0. X tends to infinite. So by considering these two conditions over here, we are going to construct the trial wave function. Here I written same thing. Considering the above discussion, the trial wave function will be in the form of this one. Psi x will be equal to ax e to the minus minus ax. Here you can see, if I'll put x equal to 0, then this value will be 0, psi x will be 0. And if I'm going to put x equal to infinite, here e to the power minus infinite value will be 0. So the trial wave function for this dynamics or for this system will be this much. Now we have to consider this trial wave function and we have to find out the ground state energy of this system. So here normalization constant is your A. First we have to normalize this wave function by using the normalization condition. One dimensional dynamics we have for this problem. So normalization condition is your minus infinite to plus infinite psi star psi dx equal to 1. Here we can use minus infinite to 0, then 0 to infinite psi star psi dx equal to 0. Here in this limit psi star minus infinity to 0, there is no wave function exists. So this term will be 0. Only this term we have to calculate. 0 to infinite psi star psi. That this integral we have to calculate. So here you just you put this wave function. So here a star psi star will be how much? A star x e to the minus x. So a star is your a mod square taken outside of this integration 0 to infinity. Here if I multiply this term, it will be x square e to the power minus 2ax dx equal to 1. Now we are going to use the gamma function. Here already we have been discussed 0 to infinite x to the power n into e to the power minus a x to the power m dx. If this type of integration we have, then its value will be 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m, right? So you just compare this integration with this integration. Here n is your 2, so instead of n we have to put 2, n equal to 2, and m is your 1. Here m is your 1, here x to the power m, here x to the power 1, and here a is your 2a. M equal to 1. So the value will be 1 by m. 1 by m means 1 by 1. 1 by a to the power a means 2a to the power n plus 1 by m. N means 2. 2 plus 1 by m. M is your 1. So 2 plus 1 is your 3. Gamma 3. Okay, you just remember this integration is very important. This integration. After simplification, we can get the a value, normalization constant value, is your a 4aq to the power 1 by 2. Now normalized wave function will be this one. Normalized wave function will be here, instead of a we have to put this one, 4aq to the power 1 by 2. 4aq to the power 1 by 2 into x into e to the power minus ax. So this is the normalized wave function. Okay, so here we covered these two steps. We written the Hamiltonian, we found the normalized trial wave function. Now we are going to calculate the expectation value of the Hamiltonian by considering this normalized wave function. Here heading also I written same, expectation value of this one Hamiltonian in the state psi x means whatever the normalized wave function we found. So this one is the angle bracket h cap, general thing, or in the integration format minus infinity to plus infinity psi star. This is the Hamiltonian already we written, this one psi x dx. Now you just segregate by the two integrations. This will be one term, this will be another term. Psi star, this is your kinetic energy part, this is your potential energy part. So just separate. This is the kinetic energy part, psi star minus h square by 2m d square d by dx square psi dx minus infinity to plus psi star mgx psi x dx. Here what we have to do, first we have to consider the limit. Most important is the limit. Here I change that limit, but here see, here minus infinity to 0, this value is 0. Only we have to consider 0 to infinity. Then we have to calculate. Same thing I have been done after 2-3 steps. Here I done the same thing. I considered 0 to infinity because minus infinity to 0, 0 integration limit, the wave function does not exist. So even if from this step also you can put 0 to infinity, no problem. Okay. Now here minus psi star value we have to put, and psi value. Psi star and psi value is nothing but how much? Is your 4aq to the power 1 by 2 into x into e to the minus x. this is your psi star and this is also psi. So here psi star if I'll put, then this is the constant x e to the minus ax, okay, and another here another psi is there. Psi means again I have to put this much. So 4aq to the power 1 by 2, 4aq to the power 1 by 2. That means 4aq only, because 1 by 2 into 1 by 2. Okay, 4aq is a constant taken outside, minus h square by 2m also constant taken outside, and remaining terms are x e to the power minus ax, here d square by dx square, again x e to the minus ax dx. Here you have to do rough. This is the task that I given to you, that you have to verify in your rough, that you just differentiate double 2 times differentiate this term x, just a simple product formula you have to use, x e to the minus ax. You can found the value will be this much, x a square minus 2a e to the minus ax dx is there, dx you do by yourself, in the rough, okay. And this term written as such, mg written, again psi star psi if I multiply 4aq root over 4aq root over, so 4aq, and here already x is there, here 2 times multiplied again x, so xq e to the power 2 e to the minus x into e to the minus x, so e to the minus 2ax, right. Now integration, here I change the integration limit, because here I have to segregate what, minus infinity to 0, same thing, plus mg minus infinity to 0, same this much term, plus 0 to infinity this much term, but this will be 0, this integration value will be 0, because psi does not exist in this limit, okay. So here next step, I change the limit, that means I removed that range, limiting range, minus infinity to 0 limiting range I have been removed, only I considered 0 to infinity, and here we can get the two terms, right. Separately I have been written over here, carefully you just watch here, minus h 4aq is the constant taken outside, take, keep over here, minus h square multiplied with these two terms will be how much, minus h square by 2m, okay. Here a square x square, a square x square minus h square by 2m e to the power minus 2ax, here e to the power minus ax, e to the power minus ax, so e to the power minus 2ax dx. Then next term will be 0 to infinity minus h square, here minus h square I multiplied with this term and multiplied with again this term, here minus h square by 2m minus 2a, if I multiply, then here x e to the minus 2x, e to the minus ax also multiply, so it will be plus h square by 2m 2ax e to the power minus 2ax dx. Again I am going to show you, carefully you just watch this term, see second term minus h square by 2m, this one multiplied with this one, it will be how much, plus h square by 2m into 2a into x into the minus 2ax, same thing I have been written over here, h square by 2m 2ax e to the minus 2ax dx, okay. And then last term as such I have been written, last term is your what, this one, mgx minus infinity to infinity, but it will be 0 to infinity, 4aq will be taken outside, so it will be already 4aq taken outside of this bracket itself, okay. 4aq common for all these terms, no, so 4aq taken outside of this square bracket, so we found the third term is your mg into 0 to infinity integration limits, and here xq e to the power xq, why it is xq, already xq is there, e to the power minus 2ax dx, xq e to the minus 2ax dx. Now again I am not going to explain this one, here same thing means you have to apply the gamma function for each integral. Here minus h square by 2m a square taken outside, only we have x square minus into e to the power minus 2ax dx, here 2 got cancelled, 2 got cancelled, and h square a by m, here h square a by m 0 to infinity x e to the power minus 2x, and third term is your x cube e to the minus 2x. Already mg is there. Now we are going to apply the gamma function for this integration, and for this integration. And we can found for the first integration we can found this value 1 by 1, 1 by 2a. Here see, this is your a value, this is your n value, this is your m value. M value means here 1. So 1 by m, 1 by m means 1 by 1, 1 by 2a to the power n plus 1, n means 2 plus 1, 3 by 1, gamma 3 by 1. First integration काम खत्म. Second integration is your this one, x e to the minus 2x. So this value, integration value will be this much by using the gamma function. Third integral value will be this much. Okay, now we are going to simplify. Here minus 4aq already is there, as such it has been written minus h cot square by 2m minus h cot square by 2m a square. Here 1 by 2a to the power 3, 1 by 2a to the power 3. Here gamma 3 means 2 factorial minus this one h cot square by m a, h cot square by m into a, 1 by this term 1 by 2a square, 1 by 2a square. Here gamma 2 by 1 means gamma 2 means 1 factorial. Then this one 1 by 1 means 1, 1 by 2a to the power 4 means 2a to the power 4, gamma 4 nothing but your 3 factorial. You just simplify further. All the steps I have been written clearly. You just simplify and you can found finally the expectation value of the Hamiltonian is your this one, h cot square a square by 2m plus 3mg by 2a. Same thing it has been written over here. From this expression we found this Hamiltonian is the function of the variable a. That means if I am going to consider the minimization condition for the expectation value of the Hamiltonian, that means we have to differentiate this value or this expectation value of the Hamiltonian with respect to a. Same thing it has been written, minimization of expectation value of Hamiltonian with respect to a. If I am going to do so, that means differentiation of this one with respect to a. First term will be how much? It will be 2a. 2a means 2 got cancel, h cot square a into m, and here 3mg by 2 is the constant, 1 by a differentiation with respect to a, that means minus 1 by a square equal to 0. Just simplify, you can found a value is this much, 3m square g by 2h cot square whole to the power 1 by 3. So the value a we found this much. Now the ground state energy will be how much? The ground state energy will be how much? That means we have to put this value, this a value, in the expectation value of the Hamiltonian. That means here we have to put here. Okay, or you can write this is one equation. Suppose equation number put it as equation number 2, and put it this one is your equation number 1, normalized wave function equation number 1. So put this a value in equation number 1, we get here. You can write, put a value in equation number 2. In equation number 2 we get, you just add in your note this this line. Okay, so here expectation value of ground state energy or eigenvalue of ground state is your h cot square by 2m. See the h cot square by 2m, h cot square a square by 2m is there. So h cot square by 2m first I written h cot square by 2m. Then a value is this much, but here it is a square. That means it will be how much? 3m square g by 2h cot square to the power 1 by 2 to the power 1 by 3 is there. So square means to the power 2 by 3. Got it? Okay, to the power 2 by 3. Then second term 3mg by 2a. Here instead of a straight you have to substitute this value straight. You have to substitute this value carefully. Here you can see, if I'll substitute at the denominator, just it will be reverse. It will be 3mg by 2. First you just write 3mg by 2, then 1 by a. 1 by a means a value if I'll put over here, then it will be written as 2h cot square by 3m square g to the power 1 by 3. Okay, so here we found the ground state energy value of this system is this much. Just to simplify this expression, whatever we found, you just simplify and you can found eigenvalue of ground state energy is your this one 3 by 2 to the power 5 by 3 m g square h square square to the power 1 by 3. If we know m value, suppose m value is your 1 gram, 1 gram, then you just put 1 gram over here and all are the constant. G value is nothing but 9.8 meter per second square. H cot value is nothing but h by 2 pi. H value Planck constant value we know, and you just put all the values and you can find the ground state energy, expected ground state energy of this system. Okay, now the ground state eigen function will be what? Already we found the normalized wave function is this one, 4aq to the power 1 by 2 xc to the minus ax. This one ground normalized wave function is what? 4aq to the power 1 by 2 into x into e to the minus ax, right? So here instead of a, what we have to substitute? This value 3 m square g by 2 h cot square to the power 1 by 2. Simply instead of aq, you just substitute this value here. Instead of aq, instead of a, if I will put this one, a is nothing but 1 to the power 1 by 3, and here aq is there. So simply we can get 3m square g by 2 h cot square. Okay, 3m square g by 2 h cot square, and whole to the power 1 by 2 is there, whole to the power 1 by 2 x e to the power, here instead of a we have to put the value a. Okay, so this is your ground state eigen function of this system. Okay, so this is all about this question, whatever we have been discussed over here. This is one of the important question. May it will asked in your exam. If it will ask for 5 mark question, 3 to 5 mark question. You just practice it for your exam. Okay, next class we are going to discuss another question belongs to NET exam. Okay, thank you so much for watching this video. Thank you.